Hello everyone, this side Ankur. As I moved from there to here, I just disturbed the entire universe. By disturbance, I mean the force which is a push or pull. As I moved, I disturbed everything, almost everything around me and also the celestial bodies, the sun, the moon, all the planets. And this amazing phenomena is known as gravitational force, and this is our today's topic which we are going to understand today. Now let's move ahead and understand this with some basics. So when anything falls, it gets attracted towards the earth. We used to see this thing in our daily life. Every time this happens, the same question came into the mind of Sir Isaac Newton during the late summer of 1666. He observed the natural phenomena of dropping of an apple from the tree. So he saw that it gets attracted towards the earth. But the question is whether the apple also attracted the earth? Yes, answer is yes, due to the third law of motion, which is action and reaction. But we do not see the earth moving towards the apple due to the reason of second law of motion, which states that for a given force, the acceleration is inversely proportional to the mass of the object. So in this case, the mass of the earth is quite large. So as the mass is inversely proportional to the acceleration, the mass is quite large, so acceleration is very small. It's negligible in comparison to the earth, apple. So, but in the case of apple, the mass of apple is very small, quite negligible in compared to the earth. So when the mass is negligible and acceleration of the apple is inversely proportional, so it's quite large. So we are able to see, so it's observable. So we are able to see the apple moving towards the earth, but we do not see the earth moving towards the apple. And the same explanation is for the question that we do not see the earth moving towards the moon, we only see the moon moving towards the earth. Now, we should understand one more thing, that in a daily life, gravitation happens every second. Okay, now right now I am standing. This is also because of the same reason, gravitational force, and you might be sitting. In the universe, all the planets is also there, the sun, the moon, our earth attracts the moon, the sun attracts the earth and all the other planets by this invisible force, which is gravitation. And also this force is responsible for keeping all the planets in their respective orbits to make them revolve. And now let's understand some interesting question, that whether this force acts between any two objects present on the earth. Yes, amazingly the answer is yes. It may sound strange, but it's quite true. Let's analyze it. And the reason behind is the gravitational force, which is an attractive force. So any object, suppose which is an apple, any object having mass attracts all the other objects around it due to this force. Now, let's look at the dependencies. So first dependency is the mass and another is the distance. So here, taking first dependency of mass, so the force depends upon the product of the masses of the two objects. Now let's understand this with some diagrams of the first dependency, mass. So here, if we take two objects m, and if the mass of it is 1 Newton, then the force is of 1 Newton, F. And if we increase the mass of one object by double it and another will be same m, then the force will be doubled, which is 2F. And if we increase the mass of one object by doubling it, and another object by tripling it, then the force becomes 6 times 3 into 2, 6 newtons, as is the force dependent upon the product of the masses. Now the next dependency is distance. As the distance is inversely proportional, the square of the distance is inversely proportional to the force. So when the distance will increase, the force will decrease, and when the distance will increase, the force will decrease. So here, when we increase the d as 2d, the force will decrease by 1 by 4 times, and when the distance we will decrease d by 2, the force will increase by 4 times, 4 Newton. It's 4F. So by combining those two dependencies, force is directly proportional to the product of masses and inversely proportional to the square of the distance between them. So F directly proportional m small m by d square. Now to remove the proportionality sign and putting it in the form of equation, we need to put one constant. Right now we put here universal gravitational constant. So the equation becomes like F is equal to g capital M small m by d square. So m is the mass of one object, capital M is the mass of another object, and d is the distance. So, and the value of universal gravitational constant is 6.67 into 10 to the power minus 11. Now if you want to determine the unit of universal gravitational constant, we used to keep the gravitational constant aside. So the equation becomes g is equal to f d square divided by capital M small m. So the unit is Newton meter square per kg square. So right now today we have understood the use of gravitation, and this is quite beneficial, and this gravitation happens every time. Right now it's also happening, and so it will continue. So that's all from my side. Thank you.